Hello and welcome to the DCG development update. We are here with the platform, the core, and the mobile teams to give you an update on what happened in the past 2 weeks. We are planning this session for 1 hour. If you have any questions, please use a Q prefix so we will know that it is intended to us and not just part of the regular conversation in the chat below. We will have a dedicated Q&A session at the end to answer all of those. All right, without further delay, let's start with Sam and the platform team. Let me find the sharing button.
Yes. Hello. So tokens were worked on me, Ivan, and Paul. State sync was worked on by Odysseus and Lukasz. Evgeny worked on a feature in GroveDB, and I was working also on iOS. So my time this last 2 weeks, so I can see basically I worked until the 8th. So from the 4th to the 8th on tokens, and then basically worked on iOS the rest of the time. Well, actually, I think, sorry, that's not true. I worked until the 9th on tokens. Doesn't really matter though. But I'll get into explaining why I had to switch to iOS later in the presentation today. So let's start with platform. And
Łukasz?
Yeah, hi. I did few small items. Let's start with the platform part. So there is a long-standing PR to basically to check if we can do Wasm SDK build. It's right now in final review and should be merged, I guess, tomorrow. One unit test failing. Once it's fixed, it will be merged. Also, I got some feedback from the community with some minor issues with what we did, and it's already fixed inside that PR. And we also bumped Alpine version. That this is the base image that we use to build our Docker images. So when someone deploys platform, he uses under the hood Alpine. Previously, it was 3.18, which will have end of life on May 2025, so just in a few months. So we have bumped it to 3.21, which just was released, I think, 2 months ago or something. So that's it in terms of platform, and I've put more effort into TenderDash in the last 2 weeks. So basically some dependencies updated, new version of that RS TenderDash-ABCI library, which is a library that is between platform and TenderDash. A new version was released with some changed cargo features. But I think only platform is affected, so it doesn't break anything to the users. And also the same bump of Alpine to 3.21 was done, but it also only affects tests. And in terms of TenderDash itself, on the next slide, Balazs, can I get next slide? Thanks. So three topics. First topic is single node quorums, where we want to be able to start a development network containing only one node. And in order to do that, we tried some different approaches. Right now, the approach is that the user will be able to define in the Genesis or later using consensus parameters how many votes are needed to accept a block. And we do that in order to be able to define that if a quorum has one node, this node is good enough to accept the block. So this work is in progress. I hope we'll start some integration. We'll start to integrate it with platform and core in the coming days. I also did some maintenance of TenderDash, like removing unneeded code from StateSync, which we'll get into a bit later, improving RPC interfaces, of course, bumping Alpine to 3.21 so that all the three components will be on the same version right now, and replacing some deprecated and unmaintained tool called Gogo Proto with its Cosmos fork. Unfortunately, both versions have had some issue where they panic in some cases. So I also contributed a fix for this issue to the Cosmos repo. Not sure if there is anyone to review that in a timely manner, but like the fix is there and it's already tested and it works. And also like 14 dependencies updated in TenderDash in the last 2 weeks. Let's go forward. Yeah, and second big task I'm on is TenderDash in and StateSync. So I think Audi will give you a bit more details later about StateSync. But in terms of TenderDash, we did some work, we did some testing on mainnet, we did some performance optimization, but at the end of the day, it turned out that we need to change our approach a bit and move more logic into platform from TenderDash. So Audi is on it, and after he's done, we'll still need to refactor this code in TenderDash. Also, so like cleanup of the source code to don't use or to don't include code that is not working and is not needed. And one feature in our TenderDash ABCI that will still also need to be refactored or even like removed after the changes that Ode is on right now. And that's it on my side. I think Ode, you are next.
Yeah, hello guys. So as Lukasz mentioned, we made some progress. All the optimization that I presented last couple of weeks were implemented on GroveDB level. Therefore, in our last benchmark of mainnet state sync, we achieved the very acceptable speed of syncing GroveDB of mainnet in less than 10 minutes. Of course, a further improvement can be made, but still we are very happy about this number. Now, the further steps are the one that Lukasz started to saying about it, that we needed an architectural rethinking, and indeed some parts were moved to platform side. To be more precise, it concerns the reconstruction of platform state as soon as the GroveDB state sync is completed. And the idea is to change the way the platform state is stored in GroveDB on source nodes. So every time a new block is finalized, the idea is to store not in auxiliary part of GroveDB, but under the root tree the data that are needed for platform reconstruction. And hence, that means that those data will be synced using the state sync process. And on the destination side, the new node will be able to reconstruct platform state using those data and some others by calling core, for example. So this approach eliminates the finalized snapshots API as discussed in the previous sprint review, and it simplifies the architecture. So we are in the process of making this new design implemented. And last but not least, two more points are planned to be implemented. The one I talked the other day about being able to commit a database transaction in the middle of the process and being able to resume later if something, if an error is occurred. Remember that the state can be really big, so we don't want to force people to retry from the beginning. And also slightly different packing limits. Instead of counting the number of chunks, it would be wiser to count in a number of megabytes. So we are, I would say, in the last line. This big feature is getting, as soon as possible ready to be shipped. So thanks for listening. Next slide, please.
Thank you. Ivan? As Paul is missing, can you present some
Yeah,
of this
sure.
work? Thank you.
Yeah, I did see actually the version 9 already. We tested together with Paul tokens and implemented some fixes and logic. So it's basically he made several new screens for tokens, and that will be part of kind of platform release V2. And I heard from him he's working on the integration of the new UI, and this is planned for next version after the platform V2 and Dashiva tool V9, V09 version. Yeah, thank you.
Yeah, thank you very much. Evgeny.
Hello. Well, the highlight again, bidirectional references. This time they are in review at last, and non-batched version though, but still that's a lot. So it covers many scenarios of inserting references, overwriting items that could be referenced this way or another, and also some documentation shipped with it about how to address atomicity in GrooveDB, caching, like the Merk cache mentioned before, and how those bidirectional references work. So there are things to read. But also there is a small demo I prepared for you, just to show. Oh, no, that's not the right screen. Yes, a demo to show how a byte of them. So I'll share my screen now. Hopefully, yeah, right now.
Here.
Hopefully you should see visualizer. Didn't see it in a while. This time I'm showing visualizer, but a feature. So there is a sample database, and we have a chain of references. These ugly blue arrows striking through everything, those are references. That our target is string hello in this deep subtree. It is referenced by another reference and another reference, and this chain goes on and on until you stay there. Subtree and the path, test leaf, inner tree, key ref, and it all starts there. So the direction references can propagate changes. That's why they were invented. And the demo application that controls this database shall change this hello string to something else to begin with. So jump in there.
What are you
Okay.
going to change? What are you going to change it to?
You wouldn't believe it. Let me. I think I
What did you
broke
say?
something. I'm saying that I broke something.
Oh, SIGINT.
So it should be new session. Should be hello, then should be updated. Oh, yes, not hello. So we change the string to not hello, and let's memorize a node hash of one of the reference along the chain. Like on the left, it starts with E6. We shall update this subtree. Yes, it has changed because references are changing their hashes along the way. So even if we go at the very beginning of this chain, it starts with 11 here, the hash of this reference. But if we reload it, it shall be EE now because it works. It's how it works. Okay, what's next? Deletion. Deletion could be complicated because sometimes we might delete things that are not related to these references at all. And for this demo, I decided that I want to delete this deep leaf subtree at all recursively. So it will delete these subtrees under it as well as these two subtrees with references. But the most interesting part that it should not, it's not obvious that there are other references outside of that deletion area that will target it. So, well, because visualizer doesn't play nice with changes, I'll just hide this deep leaf at all. Well, it's not that fair, but let's clean it up. So next, this deep leaf shall be recursively removed. Here's code on the right, by the way. So db delete deep leaf with necessary flags like recursive and propagate these changes. So if we draw the snapshot and try to reload the root tree, we see this deep leaf is not the case anymore. We have only two subtrees left. And let's reload those two that contain those references. And references are gone as well, even though they weren't directly removed by that recursive deletion. So basically that's it.
Well, that's really cool.
Thank you.
And for people watching, they're like, some people watching might be wondering, like, why is this necessary? Why is this, why are we doing these features if they're, the reason is as we add new capabilities to GroveDB, we can use them for front-facing features in the future. Like backwards references, and also if we had like backwards references, I mean, not backwards references, but bidirectional references, and we also had like tree references and a lot of other stuff, we could start doing, probably start doing like joins, where you can query join data a lot more efficiently than currently, and it would all open a lot of possibilities, basically. So thanks, Evgeny.
Thank you.
Tokens.
Okay, tokens. I think Ivan, you go first, and then I go after, right? Yeah.
Okay. We implemented the queries in SDK for tokens groups. It's like 6, I think, or even more, I think, queries, and tested them together with the -evo tool. So we went through the entire process, updated DAPI, and fixed the proof verification. There were some issues, and it's I would say it's done. There is some tests not passing, but those tests are fixed in another branch, which needs to be merged first. And finally, then Sam has time to review and merge this one. During the testing of the queries, we found some issues in state transitions, what were implemented previous sprint. These issues were fixed as well, and the PR is merged. The granular integer document property types, this not related directly to the tokens, but that was the fix through the feature. I would say this way. So we had an issue in proof verification for the tokens when historical documents are enabled. So it means that every action, every event happen, the tokens, so transfer or freeze or whatever you're doing, minting, burning, it's recorded as a document into system contract, new system contract that calls token history contract. And there were some issues related to the types of the data in these documents when we verify the proofs, and they not matching with the system types in the drive runtime, for example, for token amount. So we decided to fix this problem from other side and implement the feature what we wanted for a long time, when you can granularly define the, not directly though, but define the type for the document property. So for example, if you use integer and set maximum 0, it means it cannot be negative. So internally in Rust, it uses U64 and things like that. So it's
Can I add a little explanation here?
Of course.
Yeah, so in software systems, numbers, like, which are integer, can be represented on a number of bytes, which is the size on storage. So the most common one used right now uses 8 bytes, which is a U64. But 8 bytes is actually quite a lot, and it can store a number so big that nobody really, sometimes you don't need that. Sometimes you just need, a number up to 100, right? So depending on your use case, we now will have much smaller numbers, like 1 byte instead of 8 bytes, which will make the cost go way down for storing those numbers. Like 1 byte instead of 8 bytes, a lot smaller. And so what people will see is smaller costs. And it also, at the same time, one of the reasons this was done is because when you send a document, and you encode it and you send it to platform and then you get it back, it always comes back as a 8-bit integer, 8-byte integer. And maybe you sent it and you sent it as a 1-byte integer. So there was a mismatch when you got it back and it was weird. And that was the problem. So it's actually a great feature for 2.0, and it will make things cheaper, make documents cheaper as well.
Thank you. Thank you, Sam.
Yeah, no problem.
The token history contract, what I mentioned a bit ago, had some, the tests are not passing there, needs to be updated. I'm working on this right now. Also, we found that during the testing with Dash Evo tool, we found that in Rust SDK, we were ignoring actually the state transition execution error getting back from DAPI. So state transition has two validation steps. The first one is we call check TX. It's when the state transition is validating before it's entering mempool. It's like simple and fast check. It's happening for free, and their kind of full validation is happening when we processing the state transition as part of the block. So it's a state transition execution result. So, and we could have more errors returned depending on state transition validity, and these types of errors were ignored before in errors SDK, and this was fixed, and now we can see them there. We also noticed some usability nuance in the tokens when you define the token for the data contract. You can specify the name, the token for different localizations, basically for different languages, but there weren't any strict constraint initially. So we decided to at least add, so it should be like ISO 693, I guess. And so the two chars language code, and the English one, EN, must be by default there. So the user who is the developer who is building application and handling the tokens there, he usually can use the method of like DPP that returns always the name of the token. Otherwise, it could missing. Yeah. Oh, we also during the testing we added. It's more like developer feature, but very convenient now comparing with what we had before, because Rust SDK tests were quite painful to update from actual data, and we added convenient flag when you're starting the local network. It creates like all the fixtures for you automatically. That's speed up the development. Yeah, that's it. Thank you.
Sam?
Yeah, thanks, Ivan. So,
Thanks, Ivan.
in the last 2 weeks, I worked, as I said, maybe 4, maybe 5 days on tokens up till the 9th, maybe 10th. I'm not 100% sure. Time was kind of a blur. But I'll give the work I did on tokens and on 2.0. So I got the token claim transition working. Somebody pointed out that it was actually more of a claim than it was a release. And previously we named it release, but it is a claim. Like you claim tokens from the system, and then the system accepts that token claim. and let me kind of go a little bit further and explain how that works. So let's imagine you have the token set to a perpetual distribution. You can set anybody in the system as the recipients of the token distribution. Either like I could say Balash gets 1 billion of this token, and then he just gets it, right? And it's not a good idea that if you don't agree to something, that you get something, right? So, there are a lot of wallets out there that,
Called spam.
yeah, they spam a little bit, right? Um, so yeah, basically, you you don't automatically receive rewards from the system. You have to claim them. Another thing that had been on this is not really for tokens, but it was needed for tokens. There, ooh, a spider just went by. Okay, big spider. The storage of historical proposed blocks. So right now, if you query the system, you can get how many blocks an Evo node is currently proposing. Great. It was supposed to work that you could get that for any epoch in the past, and then actually be able to calculate how many rewards you got during that epoch. That feature was not working. So that's now been fixed. Well, it actually never was built, but now that's built and it will be present in 2.0. You'll be able to query the system for, hey, how much did I receive in this epoch? And how many blocks did I propose? And a lot of other historical information. So I think that's really cool. And because of that, we can also do token distribution based off of proposed blocks. So if you say, hey, my token distributes every epoch, and it distributes to Evo nodes based on how many blocks they propose, you can write that in your token if you want. And then I worked on distributed functions as well, and I'm going to give the different token distributions that you can choose from. They're very modular, and there's basically the idea here is to allow people to do anything they want, really. So let's go on to the distribution functions. I'm just going to go quickly through them. You can do a fixed emission. That means like every period of time. We have 3 periods of time that you can choose from, an amount of blocks, an amount of time, or an amount of epochs. So when you have a fixed emission, either every n blocks you get this, or every n time you get this, or every n epochs you get this. A random emission, you just say it's pseudo-random. It's not actually random, but it kind of acts as random. So every this amount of time, a random amount gets distributed between these ranges. Let's go forward. A stepwise decreasing emission. That's like Bitcoin does that. They have every they do halvings. Dash does 7% reduction every year. That would be a stepwise decreasing emission. Stepwise emission basically is kind of like, okay, for this amount of period, it's at this amount, then it goes to this amount, then it goes to this amount, then it goes to this amount, and then the rest is in perpetuity is this amount. All of these distributions, by the way, have a min and a max. So you can say they go to up to this amount and then they end. A linear distribution means that the distribution goes up or it goes down. Obviously, it can't go below 0. I mean, there's yeah, that's basically linear. And now become the really interestingly complicated ones. Now, these seem complicated, but remember that I did all the validation of all of this in just like a day or two. So it's actually not that complicated. It just gives token developers these options because some tokens out there do have this. Next slide. So we have polynomial emission. So you can basically map it to a polynomial distribution. And we have exponential emission. Now, these two, very low chance of being used. But if you couple this with a max, you could actually get to a situation where like on the first epoch, it's very low. Second epoch, it's very high. Third epoch, it's extremely high. And like it keeps on going up until it reaches the max. And then once it's at the max, it stays at the max, right? So that's why somebody would use an exponential, even though it's a little bit like, not very common probably. Then we have the last ones. We have logarithmic and inverted logarithmic. They're completely different in the way that they go. So logarithmic just basically goes up, but logarithmically, right? And an inverted logarithmic, it goes down but never hits the baseline. So you can use these two, and these are probably, maybe the ones that would be used the most if these get used, or probably stepwise would also be used because generally it's maybe more easy to understand. Anyways, those are the token distribution functions. I hope I didn't hurt anybody's brain.
Thank you very much. Let's continue with the core team and with Pasta. If you are here, Pasta. Oh no, Pasta is not here.
Oh no. Is anybody from core team here?
No.
Okay, well, I'll do
what
it.
a shame. Yeah.
Oh, no, I'm joking. They did tons of stuff. But I haven't been following. So basically, this is what they did. They're working on UTXO. They're working on requiring the C++ 20 compiler. So there was DIP 31 that got merged, which is the proof of service banning. This is actually going to be very good. We're probably going to get that out in 2.1 or 2.2. Well, after Core supports it, as I believe it's not. There's no hard fork required for Core to do this. So basically, it can come out as a minor Core release, and then we can just have it in Core. So what would be really? Oh, I have notes that I'm supposed to read. Okay, but I don't know where the notes are. Oh well, let me just continue then. The proof of service banning. So what's good about proof of service banning is right now when you query, when blocks are being produced in platform, we have about 10 nodes that are just offline. And when it hits one of those 10 nodes, nothing happens for about, a certain period of time, like a minute, 2 minutes, 3 minutes, while that node times out. That's actually really not good. First thing is we need to reduce that time of timeout to about like maybe 15, 20 seconds, right? We shouldn't have such a big timeout. Maybe a little bit higher than that, but maybe 30 seconds, but it shouldn't be. I think currently it's at 3 minutes. But even after that, we want to make it so like, okay, they didn't propose a block, they get banned, they get removed from the system. Maybe not immediately, maybe after a few blocks, kind of not proposing a block. And this will allow for users that make state transitions for it always to pretty much go fast, right? Right now it goes fast in 99% of the time, but 1% of the time, oh, okay, I just tried to register my identity. It took 3 minutes. And the other situation is it took 5 seconds, right? So you can get unlucky, and we just don't want people to get unlucky in the future. or at least we want to minimize this problem as much as possible.
All right. Is
Do you know where the
fine.
notes?
The notes are? Yeah,
Oh, they're in the slides, right?
there are in the slides. Yeah, and
Oh,
also in the slides. So Konstantin should be here in a bit, I guess. He just had some trouble opening the Zoom.
oh well, I'll just finish his
Okay.
note. Well, so also 22.1.1 addressed an issue with CoinJoin related balances in discrete mode. So it's basically a UI fix. So that was released yesterday.
I just joined.
Oh,
Am I
excellent.
audible?
You are audible.
Yes.
I talked about proof of service banning already. I talked about CoinJoin. Maybe you want to talk about something else? Or do you want me to finish?
I'm Konstantin. I'm from Dash core team, so I can just give some more comments what Sam did mention. We just released version 22.1.0, but it has some issues related to too many connections on the master nodes. And indeed, has been a bug related to version 2 transport. In case of some node doesn't support version 2 P2P transport, when happen a downgrade to previous version, the connection hasn't been established properly. So version 22.1.1 that has been created and built on previous week, and I believe Pascal released it in public. Fixes this issue and strongly encourage it for all master nodes to be installed. I believe it's all important on this slide, and we can go to next one. We did quite a progress for backports. On the last 2 weeks has been more than 100 backports merged from Bitcoin version 23 and other version of Bitcoin Core. And it's a pretty big amount. And we can move to the next slide. There is a list of PRs merged on the previous 2 weeks. The amount of PRs is quite big, but many of these PRs is just service PRs related to fact what we did to releases in very short time. Other things would happen, we branched out version 23 development, and once version 23 is unbranched to new branch, we can start to get merge changes what considered as breaking changes. So there is a lot of PRs has been merged due to that. That's all for core. Please, next one.
All right. Thank you very much, Konstantin, for jumping in. We have some questions for the core team, so please stay a few more minutes to answer them as well. We will get back to them.
One question is for past about CT. I believe he can answer only. And second one, I'm not sure what I can answer about spam. I haven't talked with Pasta.
All right.
Yeah, there isn't actually. So there was like a really quick few minutes of spam going on. I saw it yesterday, and I think that other people saw it too. But overall, it wasn't like an ongoing spam attack.
All right.
It was just I think that's what happened.
Yeah, thank you very much. Let's move on to mobile.
Sure. So on the Android side of things, we released kind of a hot fix 11.1.1 that addressed just a nasty little issue that came up right after we released 11.1. So that's been rolled out. We have another release coming. It's not noted here, but an 11.1.2 as well. So we finished work on most of the ability to save transaction metadata on chain. We have a little bit of UI work that we're going to do for configurations of this because it could be costly. So some people might not want to incur those costs. The issue with our Android photo picker permissions has been fixed for on the Google side of things, as far as we had to go through a whole review process. So that's been finished. Now we can actually fix the issue that we had with Android with photos getting saved on Google Drive. 24-word passphrases has been implemented. We are still doing some compatibility testing with the Evo tool and Core. So we won't release that until we've finished with that testing and kind of better understand if anything needs to be changed on either our side or any of the other sides. There's an issue with resetting the wallet, getting stuck. That was fixed. The create invitation changes has proved a little bit more challenging than we expected. Not so much just the changes for contested and non-contested, but just some other changes. I think mostly on the platform side that we haven't touched this feature for a while. So we're kind of been going back and forth between testing and fixing issues there. There was an auto logout bug, which I think we fixed that. That's in testing. And then there's a double spend scenario, both on Android and iOS, that's been in progress, and some startup failures for CoinJoin. So that's Android. On the next slide for iOS, I'll just speak to what we did on the mobile team. Sam, as you mentioned, will talk a little bit after about what he's been working on. We did roll out the full rollout of 8.3 with CoinJoin is complete. There was some work done on the sync retry logic that was finished, even though can't fully get into that until Sam finished up his work, but the initial work started on that is done, as well as some memory management fixes. Currently, he's working on user registration flow, just the different steps in that flow. And on Dash Wallet, there was an asset lock transaction fix done, as well as some changes to our Firebase events, adding new ones, changing existing ones, removing some. This is done periodically as we review the event data. We find either gaps or holes in our in what we're looking at, and some data that just isn't useful. So we'll remove some from time to time. On CoinJoin, had some fixes for crashes on low-RAM devices, as well as some display status issues and other bug fixes. Final results and UI improvements for username voting, and a buy dash fix. So Coinbase has been changing their API on us, and we don't unfortunately get communication from them all the time. So this was the second of two fixes that we had to do for iOS. Pretty much all those in review for the most part are now done, and they'll be in the next release. So that's iOS for mobile team. Sam can continue on.
Yes. So I have ventured into iOS development. This is not something I really wanted to do, but it is something that has kind of been is kind of necessary. As I said, I was working on tokens in the first few days, and I was, as CTO of Dashcore Group, I'm review people's work from time to time, especially when there are significant delays. And we got in. I identified multiple issues with the current system and how it worked. and these issues were not able to be addressed in a timely manner. So I also thought that without these issues to be fixed, we would never really release a new version of iOS, and it wasn't looking good in the fixing it without additional resources. So I went in and I've basically wrote a lot of new code, not really fixing the current code base, but actually taking elements from the current code base and writing something new that, was built from the ground up with a different architecture. And so it's going actually extremely well, mostly because of the amount of hours I've put into it. So I identified multiple issues with Pasta, who also helped me on issue identification at the beginning. So we had issues with non-rotational quorums. So currently the non-rotation quorums in core are used to validate chain locks, and they're also used to validate platform. Rotation quorums, it's a different type of technology, are used for instance send. So after I was asked for help on rotation, non-rotation quorums, I went into the code base that wasn't mine and did some fixes. And then after that, rotation didn't work. And it basically became apparent that we had to basically start in a different architecture to make this work. So that's what I've been working on. In the meantime, as I've been working on this for 10 days now, I've also identified some core performance issues that Pasta has been amazing and helping improve the performance of core requests, and a few core implementation issues on the C++ side of and these are not major issues, but fixing them will make sync a lot faster. So in the end, right now, sync works not super well on iOS. And I found that it takes 30 seconds to multiple minutes. My goal for the quorum part of sync, right, is to get this under 6 seconds. So probably like times 10 improvement in speed. That's my goal. If I can get it under 12 seconds, it's good enough. So we'll see. So what did I have to do to make this working? So currently how iOS works is all the P2P messages are written in Objective-C, and then it passes those messages that it receives to a Rust library that validates them and does all the logic. I wrote so we have a P2P library that has most messages, but it was never mnlistdiff and qrinfo were never written into that library. So Ivan actually helped me a little bit, well, actually a lot with mnlistdiff, and we did mnlist, and then I finished it and did the test, and then mnlistdiff and qrinfo we added in there. Also, there are two other messages that we also put in to get it complete and up to date with the latest Dash core. So then I built in the deterministic masternode list validation logic for non-rotated quorums, and that's now complete. And I'm working on the rotated quorums. Yes. So I also built the client application for testing DML. I'm actually putting it in the Dash Evo tool in a tab. So what does this do? It actually builds out all P2P connectivity that's required to get DML messages from core. And so now non-rotational quorums are now all validated in around 6 seconds. So 5.9 seconds for the requests and 0.1 seconds for the validation. The validation has gone down like times 1,000 in terms of just what we needed to. It's just the moving between. I'm not sure exactly what was slow before, but it was not as fast as now. And now I'm working on rotated quorum validation, and I'm also going to talk with Core to improve some P2P messages so we can get syncing a lot faster. And I have a demo to show people, and so I will present that. Okay. Can you see my screen? I don't think so.
Yes, we can see.
Oh, you can. Oh, excellent. Okay, so before we had proof log, proof deserializer. This is like the tool section of Dash tool. And now we basically have a diff inspector for masternode lists and things in here. So I'm going to start with get DMLs without rotation and validate. So just click here. And this should take about 6 seconds. I haven't done it in the background yet. So, oh, it was actually faster than that. It took like 3 seconds. So if you see here, you have all the masternode lists that were taken to validate. And also here are the diffs. So it basically gets one masternode list from here to here, and then it gets multiple other masternode diffs, and then applies the diffs between them. So if we take the last masternode list and we look at the different quorums, here are all the platform quorums that exist. The 167 are platform quorums. And you can see all of them have been validated and all are working. And that's just like I've tried this on multiple heights. Everything is working all the time now. We have no more issues. So that's nice. I haven't seen it this stable forever, actually. Even the old implementation, when I wrote it in Objective-C, wasn't this stable. So it's very nice, and it's extremely fast. So it's going to be really nice once it's incorporated into iOS. Now, as you can see, these are the rotated quorums, the 6075, and they're not valid yet because I just haven't gotten the validation working yet. Here are the chain law quorums, the 460s, and they're all also valid. Like you can click on them and it tells you like this one and the signers. There were 378 signers. There were 397 valid members for this quorum. So basically it means that 22 people got a proof of a post score here when it was created because they didn't sign in time. And if you go to like other quorums, you can see most of them got us 100 members, 100 signers. Oh, somebody got a proof of service score here, 99 signers. So yeah, that's basically, I mean, there's a lot to the validation. Back in the day when I originally wrote this validation, it took me 6 months, but having both Vladimir's code to go off of, and also having so much prior knowledge, I was able to do it in just a few days. Okay, that's that. Let's clear this and let's show. So now we have nothing here. Good. No, cancel. If we go to get DMLs with rotation and validate, and click on that. Oh, broken pipe. Let's go click it again. So this is a more. Oh, and by the way, the reason why it said broken pipe is internally, there's a ping and a pong message in the P2P system, and I haven't implemented the pong. So if you haven't talked with Core in a while, it will ping you, and you're supposed to reply with pong, and I just haven't implemented that. So it disconnects us, so then we have to redo the connection. Small thing, not very important. Okay, so here we can see that the message deserializes, and we get the mastnode list diffs. Basically, the ideal way to sync this is you're supposed to call the QR info. It gives you the mastnode list diff at the tip, and based off of that, you get all the current quorums, including non-rotated quorums. Then you ask for the diffs that allow you to validate the non-rotated quorums. And you do that really, I mean, it's a very quick process. And then you also can validate self-contained in this message all the information needed for the rotated quorum. So you get like these diffs. I mean, I can click on one. I haven't made this very pretty yet, right? I'm trying to get it working as quick as possible, but it gives you the diff here with all the information that's inside a diff. And yeah, these commitments are basically the different rotated quorums. So these are all quorum entries. And yeah, it's dip 24. It's a very long dip to explain how this actually works under the hood. And right now I'm trying to finish building it. So what is also cool about this library that I've built is that and it's already in the -evo tool, is that we will have in the future, right? I believe that we can make -evo tool once it's has redesigned UI into a fully SPV wallet, right? So basically doesn't contain all the chain, but it contains just the transactions you care about, and it can interact with Evo. It can do all like send and receive Dash Pay, and it is a good desktop experience. Also, it's built that with a library that allows it to go into browser, just also adding that information. So we could eventually put it in browser and have some way of connecting, and it's just more work, obviously, to have it secure in browser. But it's nice to have this library to be able to have instant send, chain locks, and self validation of platform messages. Okay, cool. Well, thanks.
Well, thank you very much. So let's continue with the questions, though we don't have that many. So we had a question for Pasta that Konstantin said he couldn't answer. We should wait for Pasta. When will finish SDK? Okay.
Well, so here's the thing. We're not working on SDK. It was very... we have a timeline. We have a few developers, and we can't work on everything at the same time. Our plan was to go on around 15th of March and all go into the SDK, work on it for about 2 months, and then release it fully working, right? Currently, there is an SDK, but it has issues, and those issues need to be fixed. That was the plan. In the meantime, Przemnik has been making a lot of fixes, and his team. I think it's actually just Przemnik, but I don't know if his team is on it. I'm not sure exactly who there is working on things, but I know Przemnik is making fixes there. So I believe that when we get to a month from now, we won't have 2 months of work to make everything working. I don't think it will take us that long. I think it will take us less because of the front-loaded work that they have done. But again, that is not for a complete decentralized SDK. As I've said, that is for the first iteration that makes external developers like to use it. Then there is a part 2 to that, which is the getting the SDK 100% decentralized. That requires about 3 months of work, or 2-3 months of work. It requires additional cryptography, and I do have a plan for that, but that's not in the short term.
Thank
So,
you. Yeah. So I think all the questions directed to Pasta, and I don't see any further question. Okay, so thanks for joining. Thanks for being here thanks for the comments and the questions, and see you in 2 weeks. Cheers. Bye.